Hello and welcome to Edusathi's lecture on simplifications. Let's go through the content in this topic. We'll discuss some basic calculations. We'll discuss the concept of V board mass. We'll study some basic algebraic operations. Then we'll discuss surds and indices. Finally, we'll move on to the units place value and some miscellaneous concepts. This presentation is basically to help you make calculations in a quick way when you are appearing for the competitive examination. So the first thing you need to know is reciprocals of numbers till 16. Now by reciprocals I mean converting a fraction into a percentage. So 1 is 100%, 1 by 2 is 50% or 0.5. So this is a decimal place value and this is a percentage. 1 by 3 is 33.33%. 1 by 4 is 25% or 0.25. Similarly, 1 by 5 is 20%. What you can do is pause this video for a while here and note down all these values. How are they going to help you is, let's take this 8.33 percentage here. Let's say in a calculation they've asked you 8.33% of 144. So if you don't know that 8.33% is nothing but 1 by 12 into 144, this gives you the answer straight as 12. But if you don't know that the reciprocal of 1 by 12 is 8.33%, what you'll end up doing is 833 divided by 100 multiplied by 144. Sorry, not by 100 but by 100 and then 2 more zeros. So this is a very difficult calculation to make, whereas if you know the reciprocals it becomes very easy. Similarly, let's take this figure of 7.69. If it's mentioned what is 7.69% of, let's say, 39, you can simply convert it to fraction. So this would be 1 by 13 into 39 and the answer is 3. So you'll be able to do this calculation within seconds. The second thing you need to know is squares of numbers till 30. So 1 square is 1, 2 square is 4, 3 square is 9. Now again you can pause this video for a while and note down all these values. Now where does squares help you? They basically help you in questions on series. Let's say I am given a series like 169, 36, 64, 729 and 80. Now they'll ask you what is the number which is odd one out. Now if you start drawing a pattern here, you'll not find anything. 169 goes to 36, to 64, to 729. There's a decrease here, an increase here, again an increase, and then finally a decrease. But if you know the squares of numbers till 30, you can easily point out that 169 is nothing but 13 square, 36 is 6 square, 64 is 8 square, 729 is 27 square, and 80 is not a square. So the odd one out is the number here. As we did for squares, you also need to know the cubes of all the numbers till 20. So again, pause this video for a while and just write down on a piece of paper all these cubes up till 20. The questions will be same, mostly in series. For example, you are given numbers like 64, 216, 343 and let's say 999. All these numbers, 64 is 4 cube, 216 is 6 cube, 343 is 7 cube, whereas 999 is not a cube. So this is the odd one out. Let's move on to the concept of decimal place value. A pretty easy concept, but we'll discuss. So the concept here is that after the decimal place, so this is a decimal place and I have 0 and 1. So I'll write the first number here, 10.01. If I add any number of zeros after the last digit after the decimal place, which is 1, so I can add any number of zeros here. It will not make a difference to the value of this number. Whereas if the number is before the decimal place, I am writing the second number here. So this is 10.0001. So I can add any number of zeros here and it will not make a change to the value of this number. So the rule is that for the if we have to add zeros after the decimal place, they should be added after the last non-zero digit, whereas if we have to add zeros before the decimal place, they have to be added before the first non-zero number. So we'll just solve this quickly. This is 100, the third digit is 100.1101, then I have 1000.111 and 1. So here I can add any number of zeros before this. So I add 2 zeros before this. Here also I can add any number of zeros before the first non-zero number, which is 1 here. So if we add, I have 3 here, I have 1 here, again I have 3, 2, we have a decimal point, 0, 2, 1 and 1. So the answer is 1120.2313. So this C part is the right option here. I am just discussing one question on this concept because I think that everybody of you is very comfortable with this. So let's move on to the next concept of mixed fractions. So we have three mixed fractions here, which are 3 1 by 2 plus 4 4 by 5 plus 9 1 by 3. Now in order to add them, we have to convert these mixed fractions into the normal fractions, which just have a numerator and a denominator. So how do we do that? This is a denominator here, which is 2. So what I'll do is I'll multiply 2 with 3. 2 3s are 6 and add this 1 here. So 2 3s are 6 plus 1 7. So this mixed fraction is nothing but 7 by 2 when described in terms of a normal fraction. Similarly 4 4 by 5. 5 4s are 20 plus 4 is 24. So the answer here is 24 by 5 plus 9 3s are 27 plus 1 28. So this gives me 28 divided by 3. Now I can easily solve these normal fractions. I'll just take the LCM of 2, 5 and 3, which is 30. So I have 30 here. 2 15s are 30, so I'll multiply 7 with 15 plus 5 6 are 30. I'll multiply 24 with 6 plus 3 10s are 30, so I'll multiply 28 with 10. So I'll get the answer as 105 plus 144 plus 280. 105 is nothing but 7 into 15. 24 into 6 is 144 and 28 into 10 is 280 divided by 30. So I get 529 by 30 as my answer. But if we see the answer options here, the answer options are also in mixed fractions. So now what we'll do is we'll convert the fractions back into mixed fractions. And how do we do this? We just write 529 here like we used to do in the earlier classes, and then we divide it by 30. So I know 31s are 30. This gives me 229. I'll do 37s is going to be 210. So this gives me 19 as the remainder. So what is a mixed fraction here? I'll write this quotient as 17. The remainder on top here 19 divided by the divisor, which is 30. So the correct answer is 17 19 by 30, which is the C part here. This is a very easy concept which we all have studied in the lower classes. Multiplication by 9. Instead of multiplying by 9, what we can do is we can write 8576 multiplied by 10 minus 1. So 10 minus 1 is 9. If you simplify this, I can easily write this as 85760 minus 8576. So instead of multiplying, we can change it into the subtracting operation and you'll get the answer as 77184, which is the A part here. Sorry for this. Let's move on to the multiplication with 11. Again, 5892 multiplied by 11 can also be rewritten as 5892 multiplied by 10 plus 1. So this gives me 58920 plus 5892. So if you add all these, you'll get 218 4 and 6. So this E part here is the right answer option. A lot of times in comparative examinations, they'll give you numbers like this. So I have 4 ones multiplied by 4 ones. They can also give you 5 ones multiplied by 5 ones. There's a shortcut to it. The answer will always be of the form 1, 2, 3, 4, 5, and then after a point the numbers will start decreasing. So after 5, let's say 5, 4, 3, 2 and 1. What you need to do is you need to calculate the number of ones. So I'll count here. I have 1, 2, 3 and 4. So I have 4 ones in this question in both these numbers. So the counting will go till 4. So the right option will be the B part here. 1, 2, 3, 4. Since there are 4 ones, it will stop at 4. And then again 3, 2 and 1. So similarly, if there were 5 ones, this would have been the right answer option. 1, 2, 3, 4, 5, and then it starts decreasing to 1 again. Let's try this next question. I have 98765431 plus in the increasing order. So if we add this, I'll have 9 plus 1, which gives me 10. 1 will carry over, so I'll have 8 plus 2, 10 plus 1, 11. Again 1 will carry over, 7 plus 3, 10, and then 1 again, and this process will go on. So I'll have basically 10 ones followed by a 0. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 1 0. This has to be divided by 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Now if you carefully note, I can easily write this fraction as 1 divided by 9. I can leave all these ones and I can leave all the rest of these numbers. Now if you know the fractions which we discussed in the first slide, 1 by 9 is nothing but 0.11. So this number also will be very close to 0.11. It would be 0.1123 something. But in the answer options, we have only up till 2 digits after the decimal point. So the answer is definitely going to be D part. So I was able to solve this question with just a basic knowledge of what is 1 by 9. This is where converting fractions into percentage or decimals come very handy. Let's move on to squares and square roots. So what we'll do is we'll start solving from the right side and move towards the left side. This is the process of solving these questions. So I have root 9. I know that root 9 is nothing but 3. So now I'll have 19 minus 3 under the root. I'll have 21 plus and this entire root, and then I have 41 minus this entire root. So 19 minus 3 is 16. This portion is equal to 16 and under root of 16 is equal to 4. So now my question has reduced to 41 minus 21 plus 4 under the root and this under the root. So this now becomes 41 minus, now 21 plus 4 is nothing but 25 and under root of 25 is 5. So this becomes 41 minus 5 under the root, which is nothing but under root 36, and the right answer option is 6. Again, a pretty easy question. All you need to know is squares and square roots. Let's calculate the square root of a mixed fraction. So the mixed fraction is 110 1 by 4 and I have to calculate the square root of this. So first I'll convert this mixed fraction to a normal fraction. 4 into 110 is 440, plus 1 gives me 441. So this is nothing but 441 divided by 4 under the root. This gives me 441 is the square of 21. So if I have to remove this square root, the answer is going to be 21 by 2, which is nothing but 10.5. So the answer is the B part here. A question on cubes and cube roots. If you don't know that 1728 is the cube of 12 and 2179 is the cube of 13, you'll not be able to solve this question. So first I have to solve the cube roots. So this question is reduced to under root of 13 plus 12, which is nothing but under root of 25, which gives me 5 as the answer. So the correct answer option is the B part here. Let's try a question on continued fraction. So continued fraction is a fraction wherein you'll have a question like this. You'll have fraction into fraction into fraction into fraction. The method of solving is we start from the bottom and go towards the top. So 5 plus 1 by 4 will give me, you'll multiply 4 with 5 here. Let me write down here. So 5 plus 1 by 4 is nothing but 5 into 4 plus 1 divided by 4, which gives me 21 divided by 4. So if I rewrite this equation, it would look like this: 1 plus 3 plus 8 divided by 4 plus 3. Now this 3 is divided by 21 divided by 4. This 4 will move to the top here because we can have only one denominator, not two denominators. So this fraction will be rewritten as 1 plus 3 by 8 divided by 4 plus 3 into 4 is 12. So I'll have 12 divided by 21. Now we'll solve this fraction here, which is 4 plus 12 by 21. So this comes out to be 84 plus 12 divided by 21, which is nothing but 96 divided by 21. Again, if I rewrite this fraction, I'll have 1 divided by 3 plus 8 into 21 divided by 96. So 8 into 21, I can simplify this here. I have 4 2s are 8 and 24. This again will go by 12. So this can be rewritten as 1 divided by 3 plus 21 by 12. This comes out to be 1 divided by 36 plus 21, and this divided by 12. So this is my final answer. I'll just simplify this over here. The answer is going to be 12 because this 12 will move to the numerator as we cannot have two denominators, divided by 36 plus 21 is 57. Now we have to portray this into the simplest form. So this is divisible by 3. 3 4s are 12 and 3 19s are 57. So the answer is 4 divided by 19, which is the B part here. So only a little bit of calculation required, otherwise questions on continued fractions are very easy. Now we move on to the next concept, which is V board mass. V stands for vinculum or the bar bracket, which is represented like this. B stands for brackets, O is for off. Then we have division, multiplication, addition and subtraction. So let's solve this question on V board mass. I'll just write the principle here. I have vinculum, bracket of division, multiplication, addition and subtraction. The first thing we solve is the vinculum or the bar bracket. So 17 minus 10 here will give me 7. So my question reduces to 3 minus 7. Then I have 95 minus 144 divided by 12 into 12 minus of minus 4, and here I have minus 3 minus 7. So the next thing we solve are the brackets. So let's solve the brackets. 95 minus 144 divided by 12 into 12 is 144, minus of minus 4 minus again of minus 4. 3 minus 7 is minus 4. Now there is no off written, so this goes out. Now we have to solve for division. So inside this bracket I will solve the division first. So I have 144 divided by 144 minus of minus 4 and minus of minus 4. So this gives me 1. Now I have to solve multiplication. There is no multiplication, there is no addition, so we are left only with subtraction. So I have 1 minus of minus is plus 4, and again minus of minus is plus 4. So this gives me 95 minus 9, which is 86. So the final answer is 86. So let's move on to the next topic, which is on basic algebraic operations. Now here are a few identities which you should know. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. A plus b into a minus b is equal to a square minus b square. A plus b whole square plus a minus b whole square. This is nothing but the addition of identity number 1 and identity number 2 here. So if you add both these identities, you will get 2a square, 2ab and 2ab will cancel out, and 2b square. Similarly, if you subtract the second identity from the first, you will have the answer as 4ab. A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So 2 has been taken out common, and I've written ab plus bc plus ca in the bracket. Let's try some cubic identities. A plus b whole cube is equal to a cube plus 3a square b plus 3b ab square plus b cube. This can also be written as a cube plus b cube plus 3ab, and inside bracket you write a plus b. If you solve this, you'll get the same result. A minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. This again can be written as a cube minus b cube minus 3ab multiplied by a minus b. A cube plus b cube is equal to a plus b multiplied by a square minus ab plus b square. A cube minus b cube is nothing but a minus b. So if it's a minus sign here, you'll have a minus sign here and the opposite sign here. So it is a square plus ab plus b square. In a cube plus b cube, there's a plus sign here, so you have a plus sign here and the opposite sign inside the second bracket. So a square minus ab plus b square. Now a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca. Now there is a special condition to this equation. If a plus b plus c is equal to 0, this means that this term here has been reduced to 0. So obviously this entire right hand side is equal to 0. So what I'll be left with is a cube plus b cube plus c cube minus 3abc equal to 0. I can take this 3abc to the right hand side. So what I'll have is a cube plus b cube plus c cube is equal to 3abc. We'll try some questions on these identities we've discussed. So I have 24 cube plus 26 cube plus minus 50 whole cube. So this is a cube, this is b cube, and this is c cube. If we check here, A plus B plus C is equal to 24 plus 26 minus 50, which is 0. So the value of A cube plus B cube plus C cube is going to be nothing but 3ABC here. So what is the value for this first question? It is 3 multiplied by 24 multiplied by 26 multiplied by minus 50. Since we have one negative sign here, so this value is definitely less than 0. So the correct answer for this first question is the B part, which is less than 0. Let's solve the second question here. Again, I have A as minus 526, I have B as minus 474, and I have C as 1000. If I add A plus B plus C, this will again come out to be 0. So the value of A cube plus B cube plus C cube, which is nothing but the question, is equal to 3ABC. So this means 3 multiplied by minus 526 multiplied by minus 474 multiplied by 1000. Since I have two minus signs, so minus into minus is plus, so this value is definitely positive. So the answer to the second question here is the A part, which is greater than 0. Let's try this second question here. I have x square plus y square plus z square as 121 and x, y, z is equal to 108. I have a second equation, 1 plus x plus 1 by y plus 1 by z is equal to 7 by 9. If I take the LCM, I'll get x, y, z as the LCM. Here I'll have xy plus yz plus xz is equal to 7 by 9. But I already know that xyz is equal to 108. So I can delete this xyz here and write 108 instead. 9 12s are 108. So I have xy plus yz plus xz is equal to 12 into 7, which is nothing but 84. And we need to find the value of x plus y plus z whole square. Now we'll use this identity here. A plus b plus c whole square is equal to a square plus b square plus c square plus 2 times ab plus bc plus ca. So I have x plus y plus z whole square is equal to x square plus y square plus z square, which is nothing but 121. So I'll simply write 121 here plus 2 times ab plus bc plus ca, which is nothing but xy plus yz plus xz, which is 84 here. So I have 121 plus 168, which gives me 289. I'll take the square root on both sides. So x plus y plus z is equal to plus minus 17. Since I have to find out the modulus value, so I'll take the mod here, and on this side it means that the answer is 17, which is the C part here. We have to find the square root of 11 plus 6 root 2. The only way to find out the square root is if we convert this 11 plus 6 root 2 here into a perfect square, for which we will have to use one of the identities which we've already studied. So I can write 11 plus 6 root 2 as 9 plus 2 plus 2 into 3 into root 2. 9 can be written as 3 square, 2 can be written as root 2 square, whereas 2 into 3 into root 2 remains as it is. So if I define 3 as A, root 2 as B, then this becomes 2 into A into B. So this is nothing but A square plus B square plus 2AB, which is equal to A plus B whole square. So in this case, A is 3 and B is root 2. So this becomes 3 plus root 2 square. So now my question reduces to the square root of this 3 plus root 2 square, which is nothing but 3 plus root 2, since this square and this square root will cancel out. So the answer is 3 plus root 2.